I sent one out to you already with this elliptical, the elliptical, this is called an elliptical integral or some crap like that. I forget. But this one is pretty straightforward. The one we want to look at, what we want to work on are, let me see, come on. Where is it? Here, yeah, we want to work on this box right here. Yeah, thanks, Lawrence. Good job. We want to get rid of our breakout rooms. That was a fun experience, huh? Okay, so let's think about this. So we want to do this quickly, but so do we really need to put all this into our spreadsheet? I don't know. I don't think so. I think that we have these tables we made. They're in our logbooks. All right. So we got our spreadsheet, and let me get a new one here. So we want let's see, L, and we want well, we have T5, so we have to then create T. And wait a minute, we have to insert. We have our plus minus T. And in fact, oh, why? Oh, that's right. It needs an escape character. That's an apostrophe. And no, T5. And right now, I don't know if we'll even do much with the error. It's because I'm more interested in we learn how to make these graphs. We are, oh, Jesus, right. This is, the one I gave you is for later on. Oh, look at this. I think that Lawrence has sent us the data tables. Thank you. So we're using, right now we're going to plot, we're doing what's on the lab write-up, 6A. We're working on 6A because that takes the most time. So that means we're taking the data with the length points. Everybody got that? Making the one, oh, the one Lawrence uploaded to us, Jesus. Not that's weird. I uploaded the mass table to you, but right now we're doing length and the length table. Got it? Good, good. Don't worry about it. You know, I'm moving kind of fast, I think, and I want to make this a little smaller, and I want to view. Zoom to selection. So let me make that slightly smaller. Okay, so we have 0.1, 0.3, 0.5, 0.8, and 1.0. And then we have 3.5. No way, Kenny. Just some notes like from the background. Something like we then did the data taking as a class. So, you know, I wouldn't expect you to have notes written down about, well, you could add a little bit later, like we hear these data tables like Lawrence sent to you. I don't see anything wrong. Well, yeah, you've been writing them down, so you could write the data tables would be nice, like I have in on the left here, something like that, but not the spreadsheet. No way. well, yeah, T5, 4.8, 6.9, 9.0, and 10.15. And then the plus minus is 0.2, 0.3, 0.1, 0.05, 0.25. Welcome, Kenny. And then, so remember, since this is for 5, T equals this, here, T5 divided by 5. And in fact, the plus minus is, we remember from earlier, is equal to, equal to this divided by the square root of 5. So that is, let's keep it easy. 5, nope. Right. 5 raised to the 0.5. There's a square root function, if you guys know how to use it. And then I can actually fill both of them in at the same time. And let's see. Format this, format cells, number. So I'm kind of assuming we remember how to do this from last time, some of this stuff. And this, I think, should be, I'm going to make this 3. Nice. How we doing, guys? We following along with me? Okay, so they want us to make a plot of this log of t and log of L and log of 2 pi over square root of g. But what we know is t and L. We don't know about this. The y-intercept information, we're going to find that. So we need log L and we need log of t. So now there's different, we could do this using, you can turn the axes of a chart or a graph in a spreadsheet to logarithm and logarithm. But if we did that, we wouldn't be able to do what I'm going to show you. So don't worry too much about that statement right now, but there's a method to my madness. All right, I'll get my tablet out of the way here for a moment. So this equals log, yeah, to the, oh, we want log 10, right? Log 10. open parentheses of L, enter. And then we want, yeah, that makes sense. -1 is the log of 0.1 equals log 10, excuse me, of this. Oh, what happened? Oh, I forgot the open parentheses, I think. Equals log 10 of that. And then we can do this, fill it in. And the standard for logarithms is 4 decimal places. Number. All right. So how do you guys feel so far? Are you following along with me? So you see there the log 10 of L and the log 10 of T. Okay. Now, here's our, all right, well, let's make it look pretty. Contracted T again. Oh, sure. All borders. Right. So it's T5. So I just took the T5 value and divided by 5. Good. Okay, so watch this magic. So we want over here, let's put it here. That's it. This is going to be slope. And so we expect the slope to be 0.5. So we can sort of presuppose. And then we want y dash intercepts. And for the life of me, let's see. So 6 divided by the square root of 10 is about 2. Okay. So let's box it up. And then let's format the cells. So I don't think there's been any serious difference with Google Sheets yet. So I'm hoping that we're good so far. Okay, so now we're creating a column called fitline, Fitline. And so if we look at, oh boy, somebody's got himself some virtual reality glasses. My son just came home from work. He had a delivery today. I can't wait to see this. And let's see. So our model says that, no, we're too busy. Thank you. Next time. Okay, so our x value is log of L. So this is going to be equal to, and our model is the slope times, so equals the slope here. And we, oops, remember we have to click in here to put the dollar signs. So what I'm going to do here, guys, I'm going to rush ahead and then I'll come back and re-explain it because I want everybody to see this once because we're running out of time. So it's the slope, and I have the dollar sign, so it always uses the same one, times the log of L here. and plus the y-intercept here. And I need the dollar signs one more time. Okay. So I have equals the slope times the log of L plus the y-intercept. So in principle, what this fit line should represent are the various values of log of t. Okay, so then, well, that doesn't look very promising, but you never know. So let's format cells. And since we think it should be the same, we'll say okay. All right, so here's the fun. So we have log L, that's the x-axis, right? H, and that's the x-axis, log of L. Okay, so we should be able to select all of these and insert a chart, and we want a scatter plot. And let's make this bigger. And let's, it looks okay. All right. Now, this is where I wish I had Google Sheets up, because I don't know off the top of my head how to do this in Google Sheets. But it'll still work for the time being. So, watch what happens here. Let's change the y-intercept to 1. Notice those red points started coming down. Looks like about 0.3, huh? But let's for a minute make this 1 again. Now, yeah. Okay, so what I've done is I've got the data here. I've got log of L, which is our x-axis. I have log of t, which is our y-axis, and that's the blue points. Then I have the fit line, that function. And then because all three are next to each other, I decide, sometimes what I would do is I would just first make this graph and then add in the fit line. But I took a chance because I noticed that this is X, this is Y, and this is another Y value, that it would probably work. And it did. And I'll go through it in a moment. I'll go and do it a different way. What I want to show you, and maybe, Lawrence, you mean when I change these numbers here. But watch this. So we're going to select this data point. Well, the data series we want. Whoops, no, that didn't work because it's saying format a data point. So I want to format this series. And I want to make it a line. And I like making red for my fit lines. And I want to get rid of the marker. And I'll get back to this in a moment. And that's done. All right, Lawrence, I think this is what you wanted to see. So let's change this to 0.5. Notice the line moved, right? I have it, and like, so Yeah, right, Jesus. I will also make a separate video just about doing this fit. Good job, guys. Yeah, because that's a separate topic. Because I think we all have our data. You want to look back. Yeah, see you, Marco. You want to look back at it to make sure you get your notes straight. Okay, now watch this. So it looks like the y-intercept is about 0.3. And look at that, huh? Yep. You guys, see you later. And I can also change the slope. And also, I don't like that so much. 0.5. And remember, when you do fitting, it's about having equal numbers of points above and below. So now we have set up a graph with points and a fit line. And instead of using a ruler and a pencil, finding a slope, we have Excel doing it for us. And what we're going to do over the rest, as we go through the semester, I'm going to show you how you can refine this technique that you can produce the best fit line. And I'm going to show you how to program Excel to do it for you automatically. Okay, so let's take a look. We have to do one more of these, and we don't have time for that. But what I said, like I said, I am going to make a separate video for doing this part. So right, so we have our data tables. There's graphs to be made. We already went through the mass graph. That's pretty easy. So you can get working on that. And then, right, this graph here, I think we've done our duty today. I think we'll stop here. And like I said, I will produce a separate video for the rest of the analysis part so that it'll be much shorter than this 2.5 hours. And then you can watch that at your leisure.